In this paper, we present a nanopore fabrication method only using conventional 3D printer. So usually the 3D printer printed this material layer by layer, so that if we design the pore as a 30 by 30 micrometer, the resulted pore is much larger than this. So as a manual, the G directional resolution is actually the best resolution in use of conventional 3D printer. So we just rotate the same design in G direction, and the same 30 by 30 micrometer pore is printed like this. So G directional resolution is maintained the 30 micrometer, while this XY resolution is much larger than this design. So by this SCM image, the pore is quite larger. So still it's not a nanopore, it's a still micropore. So we do something, we heat it up and pressurize it so that this deformation process make the micropore to the nanopore. So by checking this SCM image, then we can see the nanopore in between pressurized this substrate. So as a function of the deformation ratio, and also we can calculate the size as from the total resistance of the pore. So which resulted in the minimum size of the nanopore is about 30 nanometer. So to verify it's really nanopore or not, we test two things. The first one is over-emitting current test. So we put the same electrolyte concentration of the electrolyte in here and there. And then before deformation, which means only micropore, it just shows the linear ohmic response. While this after deformation, which means the micropore is turned to be nanopore, and then we clearly have a ohmic limiting and over-emitting current behavior, which prove the printed pore is the nanopore. And also the second test, the rectification test. So in this case, we put low concentrated electrolyte at the back and high concentration of electrolyte in front, and then sweep from the -5 to +5, and then this before deformation case is only linear behavior, but after deformation the same cyclic photometry was conducted, and then this conductivity is the negative voltage, and the conductivity in positive voltage has a different slope, which means it acts as a nanofluidic diode, which also prove that this formed pore is nanoscale pore.